perhaps we'll kick it off. So thank you to the students who are here with us. And if you are watching this as a recording, thanks for tuning in then too. And sorry you couldn't be here with us live. We're with Pinnwa today to learn how to code our own music. I'll let them explain that because I am not the expert. And in fact, I'm going to learn along with you. I'm kind of excited to just see how this works. I've got the program downloaded. So if you haven't yet, you do need to download the program in order to participate. Hopefully you've already done that if you're here with us live. If you're here with us as a recording, then pause the video, go download it, and then you can come back and get started with us. We are at the end of Summer Summit. This is really the last event to go up, and you need to put in your gamification codes. If you haven't, if you've been like holding on to codes for some reason, haven't checked your chat in a while, anything like that, if you haven't gone hunting for hidden ones in the resources, hint, hint, then do that this weekend. Put it in before I get to work on Monday morning, and we'll be good to go for the grand prize draw on Wednesday. So we have closing ceremonies on Wednesday at 10 a.m. my time. So that might be 30 minutes earlier for you in Labrador. And we'll do the grand prize draw for the Oculus VR headsets and the Surface Go's. You'll have the choice between the two, depending, maybe you already have one or the other, or just have a preference. So that will happen next Wednesday, but you need your gamification codes in prior to Monday so that I can start calculating things. And I will be going through like the ICTC course tomorrow and making sure I've given out all the gamification codes. So be checking that, be checking your chat this weekend to make sure that I haven't sent you any new ones, for example. And you'll get, obviously, another one for today, and a big one. You'll get a full 50 points, which is a full grand prize draw entry for attending and participating in this today. So thank you so much for joining. And if any time you have any questions about that or think you're missing codes, then send me a message, of course. But with that, I am going to hand it over, and I'm going to learn along with you from these two wonderful people who work for Pinnwa, one of our great partners that I'm so glad that we have had the joy of working with.
Lovely. Thank you so much, Shayna. We are so excited to be here with you. We're so excited to do Sonic Pi. It's going to be an incredibly fun day. So just before we dive into all of that, just to begin in a good way, we want to acknowledge the land that we're coming from. And so obviously we're virtual and we're all in different places. So I invite you to also think about the space that you're joining from and your connection to the land you're on this morning. But I myself am joining from Odawa, or what is currently called Ottawa, which is the unceded and unsurrendered lands of the Anishinaabe Algonquin Nation, who have lived here continually and eternally and have stewarded and protected these lands and waterways since time immemorial. And I think it's important too to acknowledge all nations whose names we don't know and peoples whose names we don't know, because sometimes a feature of taking land and colonization is erasing the names and histories of peoples we don't know, or we no longer know the names of. So I acknowledge as well all the peoples who have stewarded and protected all of the lands that we join on from coast to coast to coast today. And then the other thing that I like to think about when we join on kind of virtual platforms is to think about as well that these platforms also have headquarters in places and spaces. And so it's really important when we join together in virtual spaces that we don't feel disconnected from the land, but we actually get really deeply connected into the land, because there's lots of us joining from all over, and we're sharing a lot of different land spaces today. So we're grateful to be here, and we're grateful to be on the lands we're on. And we're really excited to do Sonic Pi. But first I'll introduce myself, and I'll pass it to Cheyenne to introduce themselves. And also just some little housekeeping. If you have questions at any point, drop it in the chat. At truly any point, we'll stop and we'll answer questions. And there's 2 of us here, so one of us can always have eyes on the chat. So if you have any questions, do let us know. And for those of you joining in the recording, we'll do our best to read those questions out so you know what we're answering. Yeah, so we're from Pingwa, as Trina mentioned. We're a nonprofit that does lots of kind of tech education and STEAM education. So that's science, tech, engineering, arts, math. And we do that coast to coast to coast. So this is a big part of what we do is teaching all kinds of fun things. And yeah, we're really excited to do it today. My name is Tess. I use she, her pronouns. And I am a community educator here at Pingwa and work very closely with Cheyenne. I'll pass it over to you, Cheyenne, to say hello.
Sure. Hi, everyone. Thanks for joining. So yeah, I'm Cheyenne McNenly. I use they, them pronouns, and I'm one of the digital educators at Pingwa. And I guess like outside of work, I'm also an artist and musician. So I was super excited to work on some Sonic Pi curriculum, and I hope everyone enjoys it. And again, like if you have any questions or anything, just make sure you put that in the chat and we'll be sure to answer that. So to start, I don't know if you want to start with Minds On activity test.
Yeah. Dive on in. Yeah, so we'll kind of get stretched and get our minds stretching and get a little bit ready to do code, because we're going to do lots of code today, but we'll do some kind of hands-on activities first to get into code thinking. So we're really big on our team. We love to think about different ways that you can learn and think about code, not necessarily through coding. So we're going to do a mix of that today. We'll definitely do some coding, but we'll do some non-coding first. So the first thing I'm just going to kind of talk about and then send something in the chat. Trina, I'm realizing I don't have an option to send to everyone, but maybe if I just send in the chat, if you can send to everyone. I only have hosts and panelists, or you and chat. Got it. Thank you. Lovely. Okay, so we're going to do 2 little kind of brain stretching activities before we dive straight into code. So the first one, you have probably done this before in your life, but it's to make a rainstorm with your hands. So you've probably done that activity, but I thought it'd be lovely to start something that's making some sound, making some audio experience. But what I'll invite you to think about is how you could explain that as a set of instructions for another person to do. And so I'll give you a couple of moments kind of while I'm talking if you want. So for those of you who are not familiar, when you make a rainstorm with your hands, it's like rubbing your hands together or snapping or making different kind of clapping motions to make the sound of a rainstorm. And so you build up those sounds over time until you build up to like clapping or stomping, something kind of loud. But what I invite you to do is think about how you could write that out as a set of instructions, because this is one of the most important things actually that we ever learn how to do in code, is to create algorithms, which you may be familiar with. And actually, while I chat as well, I would love for you to share in the chat where you're coming from and what grade you're in, and also if you have any coding experience, just to give us a sense of who's joining us today, but we'll make it totally accessible for everyone. But anyway, so back to what I was saying, algorithms are kind of the cornerstone of coding. And when we say algorithms, sometimes that can feel like a big, scary word. But what it really just means is a set of instructions. So you follow sets of instructions actually all the time, every single day. Every time you follow a recipe, every time you bake something, every time you brush your teeth, that's a set of instructions somebody gave you at some point in your life, and you are still following and executing those instructions every day. So that's really all an algorithm is. It's a set of instructions. Oh, lovely. Yes. So if you want to, if you want to actually unmute, and I'll invite Trina and Cheyenne to unmute, so at least you can hear us do it together. But if you want to unmute and join our rainstorm, you're really welcome to. So anyways, so if you have done that before, I invite you to just take a moment and think to yourself, how would I teach somebody else how to do that? How would I explain to somebody else how they could do that? But what I'm going to do is I'm going to share for you a quick algorithm in the chat, and then we're going to execute it together. I've included time. So I've included kind of 5 seconds for each step, so that I'll just invite you to count in your own head and execute along with us. But it's also kind of an interesting experiment to see, because we're in different places and different time zones. So our 5 seconds might be a little choppy and a little bit at different times, but that actually just enhances the rainstorm. Oh, okay. It sounds like maybe you are not able, I'm just seeing in the chat, you might not be able to unmute, but that's totally fine. Cheyenne and Trina and I will do it, and I invite you to join us at home. So I'm just going to drop this in the chat for you, and then I'll give you kind of a countdown, and we'll all do this together. But as we do it, I want you to think about how I wrote this out, if it could be written more clearly, if there's a better way to design an algorithm like this. So we'll do, there we go. Okay, so I've just sent it in the chat. So I'll give everybody just a moment to open up the chat and get that set. So I'll also just explain beforehand, rubbing your fingers is this, tapping your fingers is this, clapping is this. Oh, sorry, snapping is this. I think I said that's snapping. This is snapping, clapping, and then stomping your feet, which you might not be able to hear my stomps because it's my audio setup, but hopefully you can hear your own stomps. So if everybody's ready, and Cheyenne and Trina, if you want to unmute and join me, that would be lovely. So I'll give you maybe a 5-second countdown, and then we will start our rainstorm. So we'll start in 5, 4, 3, 2, 1. Lovely. Thanks everybody for joining in. So maybe it was hard to hear. I was trying to go as close to my audio input as possible, but hopefully you were also doing it yourself. But thank you for playing along with us. I love that. I love building a rainstorm together. And as I said, I love thinking about how it is an algorithm, just like almost everything. Anytime you give somebody instructions, those are algorithms as well. So before we dive into code, we're going to do one more kind of quick little hands-on activity. So on the same vein, we're going to keep thinking about algorithms and how algorithms can be executed. And another thing that hopefully we'll learn is that you have to be really, really specific when you design algorithms. So before we started, I explained to you what each of those steps looked like. I gave you an amount of time for each of the steps. So that's really important, because when we teach computers things, which is basically what we do when we're coding, we're teaching a computer how to do a new thing. We can't assume that they know any of the things that we know naturally. So some of the things that are obvious to us, like for instance, even what clapping is, it might not be obvious to a computer until we teach them how to do it. So it's really important that we think really specifically when we start moving into code spaces, and Cheyenne's going to cover so much of that kind of thinking as well in Sonic Pi. So the other little quick thing we're going to do, and we can hopefully do this kind of at the same time, is I'm just dropping a link for you in the chat to a Google Jamboard. And so a Google Jamboard is just a little kind of drawing space if you haven't used one before. And it's pretty simple the way the drawing tools work. So I'm just dropping in the chat, and while I do that, I'm also just going to share it on my screen so you can see it as well. Let me just get that open. I will copy this in here as well. Okay, so let me share my screen. There we go. Okay, so this is the Google Jamboard, and if I'm not mistaken, I did just drop the link in the chat. Yeah, I did. Okay, so as I said, Google Jamboard is just a simple little drawing tool. And what we're going to do is a little game we like to call algorithmic drawing. So we're going to create a drawing using a set of rules. This is actually kind of inspired by the work of an artist named Sol LeWitt. So actually, let me just share a different screen. I'm just going to share my Sol LeWitt screen just so you can see. But Sol LeWitt is an artist who has made all kinds of really interesting and exciting art. But all of Sol LeWitt's art is designed based on algorithms. So I just pulled up my Google image search here for Sol LeWitt, just so you could see a little bit of his work. But you can see there's all these like beautiful, complex murals and line patterns and color patterns. And Sol LeWitt, actually, the artist right here, never would paint any of these creations. What he would do is create an algorithm, so a set of rules, give it to somebody else, and then they would actually make the painting on the wall. So Sol LeWitt's very famous for a series called wall drawings, which are things that look like this, where the instruction set might be draw only straight lines. Each line should be horizontal, vertical, or diagonal, and draw them all in a square, for instance. So that might be the rule set that a person was given, and then they actually create the art out of it, which is really cool. So we're going to do our own small scale version of that today. So I'm going to paste this in the chat as well, but I put it on the Jamboard. What I'm going to do is give you an algorithm, and I'll give you a couple of seconds or a couple of minutes maybe to execute the algorithm. So basically you have a set of rules here. You have 3 instructions. Your instructions are use only one color, draw only straight lines, and each line must touch a previous line. And I'll just invite you to find some space on the Jamboard page here. And if we run out of space up at the top here, you can just click this arrow and it will add a new page, and you can just do it on your own page. But I'll stop sharing for a moment while we do this. For those of you who haven't used Jamboard before, there's, as I said, there's just pen tools up here. So you can draw with your pen tool. You can change the color, you can change the size, all that kind of thing. So if I was using only one color, maybe I'm going to use black, and I'll draw only straight lines. And I've already not followed the algorithm. Each line must touch a previous line. And so I'll give you a minute or two and we'll see what we come up with. And there's no wrong answer. It's just a fun drawing activity, but I'll stop sharing so you don't have to feel like your work is being broadcast live. So I'll stop sharing, and I'm going to drop the Google Jamboard link in the chat again, and I invite you to join us on this and do a little drawing. So maybe we'll do this for just a moment, and I'll maybe play us some music while we do it. Wonderful. Thank you so much for joining and participating. I'm just going to share the screen super briefly, just to see what we came up with. Thanks everybody for joining. It's so nice sometimes when you're in virtual space to be able to share computer screen space in some kind of way. It was so nice seeing everybody's cursor move around. Lovely. So thank you very much for doing this. And you can see what is so exciting and interesting about this is that we can design algorithms that can have lots of different outcomes. And you'll see that today, the code that you do with Cheyenne, there's going to be lots of different ways in which you can kind of tweak and modify that code so that lots of us can get really, really different outcomes from the same or almost the same code. And you can see that here on the screen. It's like a great example of that. We all had the same rule set, but we've all drawn really different things. So thank you so much for playing along. So I will stop sharing and I'll pass it over to Cheyenne to get us started in Sonic Pi. I believe the link is in the chat if anybody still needs to download it as well.
Awesome. Thank you, Tess. So yeah, we'll get started with Sonic Pi. I'll just share my screen. So I'll show you guys a quick video first. But yeah, so Sonic Pi is an open source program where you're able to code and perform music through code, which is super fun. So through that, you're able to learn different music concepts and whatnot through code, and also learn different coding concepts by coding music, which is super fun. So this video here, can you see my screen okay? With the YouTube video? Okay,
yeah,
perfect. So this little video that I'm going to show you is a live performance done by Sam Aaron, and Sam Aaron is the creator of Sonic Pi, and it's super cool. It may look a lot and we won't be going like this far, but this is just a possibility that you could do if you dive really deep into it, which is super cool. And again, this is like a live performance, so you're able to do some like live coding and whatnot, which is super fun. But I'll play this just to give you guys a little taste of what you can do. Yeah, I hope you guys could hear that okay, but I think this is so cool. And we'll be touching on different things that you could kind of see on the screen here. And again, please leave any questions or comments in the chat and we'll be sure to answer those. So yeah, so let's get started. I will show where here. So first I'll just kind of start off with Sonic Pi itself and kind of give you guys a little tour of that. So to start off, this is kind of your main coding environment here. So this is where you'll put the code, and as you can see, there's going to be like different lines and whatnot, which we'll get into afterwards. Up here's your play controls. So here, run, this is where you'll run and play your code, and when you press that, you'll be able to hear your code play as well. Here's just to stop. You're able to do live recordings of your code as well. You don't always have to do that, but if you want to create some type of like wave audio file, you can do that and save it here, and then also load any previous saved wave files. But for the most part, everything saves automatically just on the Sonic Pi. That's just to kind of do like an external save if you'd like. Over here is the scope. So here, when you're running your code, you're able to kind of see the wavelengths, the sound lengths of your code playing here. The log and cues just kind of shows what your computer is reading, like just the code here. And usually if there's any little bugs or mistakes in your codes, you can kind of see it here, and it will also pop up at the bottom here as well. Here is just kind of some general settings, so just like sizes to fix the size of Sonic Pi. Here you can just kind of close the scope if need be. Info, just kind of general information on Sonic Pi itself, and same with preferences. And then help, you can click there, or you can also find it at the bottom here. And here you can find tutorials and examples. And also when we get into kind of more in depth with different things for like synths and effects and whatnot, you're able to find the codes there as well, which can be super helpful because sometimes you'll see later on, but there'll be a drop down to find the code. But if that doesn't work, you're able to just find that in the help section below. And then also we have buffers here. So there's 10 different buffers. And I guess in easier terms, it's just kind of like different tabs for different projects. So here you can see like different things I've worked on. And usually you can't really, like you can play them all at the same time, but it can get a bit messy. But for the most part, it's just like a different tab for different projects that you're working on, and it all auto saves, which is fabulous. So I don't know if there's any questions or anything with that, or if everyone's good to move on, we can do that. Okay. So to start, let me just see here a moment. So in Sonic Pi, so to code music, there's different notes, and within music, there's 7 traditional notes, which goes from like A to G. And in Sonic Pi, you're able to represent notes through like the traditional letters, or you can also represent that in numbers as well. So I'll just show you guys one more thing. Can you see this okay? Good. Okay, perfect. So here's kind of like a traditional keyboard. And you can see like it starts from C and goes all the way to B, and then you have like your 7 notes included in that, like the A to G. And then there's also different octaves. So with that, like the lower you go kind of on the keyboard, like the lower the notes will sound. And then again, like the higher you go, the higher the notes will sound. And in Sonic Pi, I believe there's 9 octaves, but you can hear them best between like octave like 3 and 6, I believe, for it to not be super low or super high. Because you'll see when you guys play around, if you make it super high, it is very ear piercing. But you can also see here, so say, for example, octave 4, you have the C, D, E, F, G, A, B, but you can also represent that through numbers like 60 to 71. So in this slide, here's kind of like a little cheat sheet. So you can see, so say if you want to play C on octave 5, you could do 72. Or another example would be like G on octave 8 would be 114. So there's different ways to kind of code notes. And in this one, we probably won't go into like sharps and flats and whatnot, but there's options to do that as well. So I guess we'll start coding now. So I guess if you guys just want to copy the code that's on my screen, and we'll also put it in the chat because eventually the codes are going to start getting long. But again, if you have any questions, just put it in the chat. And once you're done to move on, just give me a thumbs up or something in the chat, just let me know. So to start, we'll just code a note. So to do that, it's just play space colon C. And you should be able to hear that. And whenever you're done writing your code, if you just press run, you're able to hear that. Tess, are you able to just see the Sonic Pi screen?
Yep, just Sonic Pi.
Okay, perfect. So I hope everyone has got that done. And so to kind of show you a comparison of like the numbers and letters of notes, to do that, so we did like a C. So to do the numbers, you can just do 60, and if you play that back, it should sound the same. So there's no really big difference with that. It's just the way that you write the notes. Mhm. And then to go back to the traditional notes, so how I was talking about octaves, so like with the numbers, you can just kind of change the number to represent the note in a certain octave. But if you want to change the octave using kind of like that traditional letter note, you can just put a number beside it. So this would be like C in octave 5, or if you want to make it lower, you could do C in octave 4 and so on. So you can do that between numbers 1 and 9. And that just allows you to change the octave coding, the notes in this way. So next, to code a chord. So a chord is just notes played at the same time. So like on a keyboard, say if you press down on like 3 different notes, that would be a chord. So to do that, and again, I'll just show you the comparison between using the numbers and letter notes. So here, this is a C chord. Using the numbers. So for that, it's just play underscore chord space with the brackets 72, 76, and 79. And the important thing to remember with writing code, you have to make sure it's written precisely and like correctly in the like the coding language that this program uses, because if not, it'll kind of like create a bug and won't run correctly. But again, if that happens, like something will like pop up in the bottom just to let you know. So if I were to do that, like it kind of like lights up to let me know. And usually like something will pop up on the bottom, but yeah, I'll just give you guys some time to do that. On perfect. And Tess is writing the code in the chat. Thank you. And if I'm going too fast or too slow, again, just please let me know in the chat. I just want to make sure everyone's following along. So I'll give everyone like another minute to just finish that up, and then I'll show you the same chord by just using, again, like the traditional letter notes. Okay. So it's pretty similar, but here it's like in the brackets, you just have chord space with the colon C5, kind of like we did before. And here you just kind of indicate if it's a major or minor note. Okay. So the next part that I'll be covering is another code to play a pattern. So if you play this code back, you can see it plays everything kind of like at the same time. So again, like this code, it'd do the chord of C. So I play the 3 notes that create the C chord all at the same time. But this code will play each individual note that's in this chord. So once you play that, you can kind of hear the difference with that. And this code's also pretty much the same. You just change like the chord to pattern here. Yeah, and again, like playing with like the octaves too, you can definitely find a more pleasant sounding chords with that. Because like again, if you make it very high pitch, it is terrible, and then super low, you can barely hear it. So again, I can give everyone like another minute or two just to play around with different chords and octaves and everything. So again, like with the chords, you can use anything between like A and G. And if you want to change the octave, you can use any number beside that between 1 and 9. And if you want to use the numbers, like the number notes, you can use any number between, I believe it's like 1 and 126. So if you want to play around with that, I'll give everyone about 2-3 minutes to do that, then we'll move on.
I'll also just throw in it's kind of a fun way to test your hearing. I don't know if you've ever used those apps before that play sounds and then guess your age based on them. So as you get older, you actually lose the ability to hear, especially sounds at the higher frequency of your hearing. So the older you are, those high pitched sounds, you actually wouldn't be able to hear. So you can kind of see how high you can go and actually still hear something coming out of your computer.
So I'll just give everyone 1 more minute to just finish up and then we'll move on. Okay, so next, start kind of like creating like a little melody. And so melody is just kind of like that catchy, memorable part of the song. It can be like a little tune, a voice, a little line of the song. So it's like a sequence of oh my goodness, getting tongue-tied, individual notes that kind of sound good together. So what I put here, I just put a few notes in the chat, or not in the chat, on Sonic Pi. So as you can hear, kind of like please like each note. And if you want to start kind of creating more of a melody and whatnot and kind of break up that sequence of notes, you're able to use this code, which is called sleep. And that just allows you to add kind of breaks or rest in between notes. So this number here kind of represents like the number of beats. So it'd be like kind of like 1. And then if you put 2, it'd be like 1, 2. And for this, you can put any number between 1 and whatever you'd like it to be. But again, that just kind of allows you to break up those notes and give you rest between notes. So next I'll kind of cover on how to repeat kind of this code that we did. And again, you can use this code for other things that we'll be doing. So this code here, so this is to create repetitions of sequences and sections of code. So as you can see here, it says 2 dot times do. And this will allow your code to run twice. And again, here you can change the number to whatever number you'd like to repeat. So again, you could put like a 4 or 6 to just repeat it that amount of times. And you'll start seeing this a bit more the more that we code. And here, so you'll see do, and anytime that you see that, you're going to have to end that sequence of code by putting end, because if you don't, your code just won't work. So just keep that in mind, and I'll keep just bringing that up, because like when I first started, I always forgot to do that, and I was wondering why my code wouldn't work. But yeah, so anytime you see that do, you always put an end at the end of the code to close that. And yeah, with your comment, Trina, I had a student actually, she wrote the intro to like Crash Bandicoot, like this video game. She kind of figured out the notes for that and kind of recreated it in Sonic Pi, which is super cool. So it's a really neat way to kind of play around with like creating your own songs, but also recreating songs that are already made and kind of remixing them a little bit and just hearing like code play it. So it's always fun. Okay. So another fun thing, so with this code that we just did, you're able to do kind of like that repetition inside each other. So you'll hear once you run this, there's kind of a more intricate sound to it, which is super fun.
For those of you who do have some code experience, the do and end pairing that Cheyenne was just talking about, it's like a loop in any other coding language you may have used before. So for instance, if you're familiar with Scratch, where you use like a forever block, which repeats things over and over, or a repeat blank times block, which repeats something a certain number of times, that's exactly what kind of the do end pair looks like, just in a different code space. And you can see loops in every coding language ever. So there's something that repeats a process some number of times, or kind of an infinite forever number of times.
Okay. Yeah, so I'll just give everyone one more minute to finish that up and then we'll continue. Okay, so the next thing we're going to cover, as you can see, the codes are starting to get longer here, but when you start running those, you can definitely hear kind of like the cool sounds and kind of the complexity that you can get out of it. This is where we can start kind of creating like more melodies and rhythms, and then we're going to start kind of layering things. So with that, this code here, in thread do, so this kind of allows you to kind of separate and allows you to run sections and sequences of code separately from one another. And this kind of allows you to layer different sounds. So again, and also just a reminder how you see these do's here, just remember to put the end to close those off. But here we have one thread, so this will kind of like run its sequence and whatnot. By how we have another thread, this will run independently from this. So this is again where you can kind of start creating those layers. So I'll start moving on. Again, if you need more time, please just let me know in the chat and I'll take a longer break just for you guys to finish up. But if everyone's good to go, the next part, and this is where it gets like really fun, extra fun. So this is where we can start adding and like kind of changing the sound of your code. Because as you can hear, it's just kind of like a standard little bell kind of thing. But here, so the synth, I don't know why this is not working. Uh-oh. Yes, I might have to just like close and open up my Sonic Pi again because it is having some difficulties. But yeah, so just take this time to kind of play around with like different notes and different sleep time and whatnot, just to hear the different sounds and whatnot you can make. And then we'll get into adding synths, which is super fun.
Maybe we can take a really short break if anybody needs one while Cheyenne gets set back up. And so you can play along with us and yeah, edit that code and test it. Or if you need a second to stretch your legs, maybe we'll come back together in like 3 minutes, which is 9:35 for us, which was probably an hour and a half forward for a lot of you. I'm terrible at time zones, but in 3 minutes, we'll come back together.
So I'll just give everyone like another minute to just like settle in and just finish up what they're doing. So I'll just show like a little video of just like someone kind of using a synth, and then we'll kind of go forward and start coding synths and whatnot, which will be super fun. So it looks kind of wild here. Lots of like chords and different things. And here it's just like when you move these like little patch cables here and turn knobs, you can get like an almost an infinite amount of sounds, and you can kind of like recreate this in the simplest form in Sonic Pi, which is fun. Like luckily you can just kind of like code and like use a little synth, and it'll kind of do all this fun stuff for you. But I'll just kind of play this video just to kind of show you. So like with that, you can kind of like recreate like those types of sounds again using Sonic Pi. So back to this code that we were just working on. So to code a synth, I'll just use this code here. And like I mentioned before, this drop down menu will come, or like drop down. But again, if you can't find that, you can just go into the synths here and scroll down for whatever one you'd like, and you can just copy the code right there, if that's easier, or if the drop down menu doesn't come. Then we'll do one down here. And then I believe my sound might work on this now, but I don't know if you can hear this. Perfect. So you can kind of like hear how it changes the sound. And then again, I'll give everyone time to play around with different synths. This is always kind of like my favorite part, because you can get some really interesting sounds with that. And there's lots of like neat options too, which is super fun. So like kind of like that video I showed everyone, you can again kind of recreate different sounds like that by just using this code. So again, just like playing around with that, you can hear like all the different sounds. So I'll give everyone maybe about like 3 minutes to play around with that, and then again we'll move on.
I just dropped this in the chat, but for those of you for whom the term synth is new, when we say synth, it comes from the term synthesizer, which emerged in the music scene in probably in a big way in probably the 70s, 80s. But basically what it means is an electronic device that can synthesize audio. So it basically just means some kind of electronic system that can create waveforms, which are what audio is made out of. It's made out of waveforms. So that's all it means. So when we say we're using a synth, we're using a specific kind of waveform creation. And so you can see Cheyenne was just showing you how they can edit the synth and it changes the sound of the audio. So definitely play along. I know for me, when I learned Sonic Pi, I learned everything basically just by playing around and testing with code that I already had in front of me.
So I'll give everyone until like, well, I guess our time, 9:45. And again, I'm not good with time zone changes either. So I'll give everyone another like 4 minutes, whatever your time zone is, just to play around. Because like Tess said, it's like you can learn so much just by playing around and experimenting. So yeah, I guess 4 minutes, we'll come back together and then keep moving on.
Just in case anybody didn't catch it, where Cheyenne has clicked on the bottom of their screen on the bottom left, yeah, right there where it says synths, you can see the list of available synths in Sonic Pi. So you can test from those. I also just dropped some in the chat that you can try adding. But if you're looking for more synths, you can see them actually in that synths list on the bottom of your screen as well.
Okay, so I hope everyone had some fun playing around with that. So the next thing that we'll be covering is loops. So kind of similar to the code that we did with like the 2 times do and whatnot, like the repetition. Loops kind of allows you to like repeat that section of code kind of infinitely, so it just will play over and over again. So here for that code is just loop space do. And again, just how you see that do, you have to close that with the end. And once you run that, it will just play this code over and over again. And this kind of helps too if you want to make like a super like long song and whatnot. And then with like different sections, that's a great way to do that.
Now that you have code that loops infinitely, I know Cheyenne said it at the beginning, but just so you remember, right beside the run button at the top left of your screen is the stop button, because the looped code will just keep going. So you can hit the stop button to stop playing it.
Yes, thank you for mentioning that. Like I did a Sonic Pi course with some younger kids a few weeks ago, and they really enjoyed the loop option. So it's always good to remember that there is that stop button. So the next part, I guess I get a new buffer. We can do this. So again, we'll be using the loop again, and we're going to start using samples. So sample is just kind of like a little like snippet of a sound and whatnot. And in Sonic Pi, this is where you can kind of start creating like drum beats. There's different like guitar and bass and whatnot, and just like other fun little samples. So for this again, we can kind of start creating drum beats, which is fun. So I'll just give everyone some time to copy that down. And I'll also give everyone an extra like minute or two just to play around with the different samples. Like you don't have to just use the drum. And again, like down below here, kind of where the synths are, you can find the different samples here as well. So let's give everyone a few moments to just finish up. And then I'm just going to show you a quick little video. I'm just kind of explaining beat and rhythm, because the next part, how we kind of got that loop with the drum beat kind of down, we're going to kind of make a more complex drum beat to add like a beat in our music. And then at the end of this, we're kind of going to layer everything that we've learned to just create one whole song, which would be super fun. So I'm just going to play this video, and again, if you have any questions for like anything we've covered before or now, just again, please let us know.
Composer, producer, or anything in between, this video is for you. So let's dive on in. My name is Joshua Witrado, and I'm a performing musician and a band director. Welcome to part 3 of my series on music theory, where I break down the fundamentals of how to read and write music. In part 1 and part 2, I talked through how to identify music notes on the staff using the treble clef and the bass clef. This video is going to focus specifically on the difference between beat and rhythm. Every new video in this series will build off of the previous video, so if the content here helps you in any way, consider sticking around to see how everything fits together. Let's get started. Oftentimes, the words beat and rhythm can get mixed up in conversation. People might say the word beat when they actually mean rhythm, and vice versa. But beat and rhythm are two very different things. And before we can define rhythm, we first need to define the word beat. The beat of a piece of music or a song is typically felt in the body as a natural movement to the music that we're listening to. If you have your favorite song on and you find yourself nodding along with your head or tapping along with your foot, you are moving to the beat of the music. The beat is constant and doesn't change. It acts as a pulse throughout the music and anchors the other parts of the music to ensure that everything fits together smoothly. You can also think of the beat of a piece of music or a song like a heartbeat, in the sense that it's a steady pulse. But heartbeats can also vary in speed. They can be fast or they can be slow. This is where we get the musical term tempo, which defines the speed of the music. In pop music, you may hear the term BPM, which stands for beats per minute. If the tempo of the music is 60, for example, there will be 60 even beats per minute, essentially 1 beat per second. If the tempo of the music is 120, for example, there will be 120 even beats per minute, or essentially twice as fast. Tempos can range anywhere from really slow at, let's say, 40 beats per minute to really fast at, let's say, 220 beats per minute. But those are just two examples. The tempo of a piece of music can definitely be slower than 40 or faster than 220. But no matter what the tempo is, the beat will always be steady and even. And now that we've established what the beat is, let's talk about rhythm. Rhythms are sounds or notes that can vary in duration. Unlike the beat, where the notes are consistently the same duration apart from each other, rhythms are made up of combinations of short and long notes that move on top of the beat. And where the beat is constant and doesn't change, rhythms are constantly changing. There are so many different combinations of rhythms in music, and that's what sparks interest in the ears of the listener. Let's take our steady beat again, for example. If we listen to a whole song that was just a beat like we have here, it may be interesting at first because it would be something fresh for the ears to listen to. It would establish the tempo or the speed of the music, and it would be something we could feel in our body, either with a head nod or a foot tap. But after a bit, our ears would become familiar with the constant beat, and when nothing changes, the music could become a bit stale or boring to listen to. But let's throw some rhythms into the mix. We are immediately pulled into the music by the changing rhythms on top of the beat. They give our ears something new and interesting to pay attention to, which, as the listener, gives us a reason to continue listening to hear what happens next and how the rhythms change. When we think about rhythms, we should think about these types of notes, which are the rhythms that we most commonly see when we look at written music. Be sure to check out part 4 and part 5 of this series, where I break down each.
Yeah, so that's just like a little background on that. So What did I do? So now we're going to start coding kind of like a more complex drum beat. Once I find it. There we go. Yeah, so here, so rather than using just a standard loop like we were doing previously, here is like a live loop, and this just kind of helps these loops here sync well together, because as you can see, there's different sleep times in between and whatnot, and sometimes how it's coding, it can get easily like kind of clustered, I guess. So this live loop again just helps it kind of stay synchronized with one another with these different loops. And the difference with this as well, so here you have to kind of give like a unique name to each loop, just so like the computer knows it's like, oh, this is one loop and this is another, just to kind of separate them. And here it's pretty like straightforward: drum, cymbals, hi-hat, but then you can pretty much name it whatever you want as long as it's different from the other loops. And then as you can hear, you kind of get that nice little drum beat going on. And just to add in quickly, as you could kind of like see in the video, you can also kind of start changing the tempo. So for that, we can use BPM, and again, that's like beats per minute. So like the higher the number, like the faster the tempo will be. So again, I'll give everyone some time to play around with that too. And playing around with the tempo is always fun too, because you can make it sound crazy fast or like super slow, but just playing around with those numbers, you can kind of find that nice tempo that you'd like. Just because it's a bit of a longer code, I'll give everyone like 5 minutes to get that down and also just play around and experiment with that.
Just a reminder for those of you following along live, the code is in the chat. And for those of you who are maybe following the recording, we'll make sure that there's somewhere where you can reference the code. We'll share a Google document as well, so you can reference the code as you're going through this.
Yeah, after this, I'll send a document to Trina, and she'll send that out to everyone with the codes and just kind of like a little cheat sheet of like explaining what each of the codes kind of do. So hopefully that will be helpful for everyone. So I'll just give everyone a few moments to finish up and then we'll move on. So this code here is called play pattern time, and this code kind of allows you to play specific notes kind of in a pattern. So similar to like the chord code, but this rather than making a chord, you just can use whatever notes you'd like. And so in this bracket here, so these are the notes. And then in this bracket here is kind of like the sustain. So that just means like how long each note will be played out for. So again, like for example, this would be like G will play out for like 2 notes, and then A will play for another 2, and so on. And so for the last part, which is an also super fun part, is adding effects. And you can add effects to pretty much like any of the codes, like including like the synth one we did, the chords and whatnot. And so for that, again, pretty similar to adding like synth and samples. You can find that here. So with underscore effects. And then again, you can kind of see like that drop down menu. And again, just a reminder, you can find the different effects down below here in the help section. And let's see which one. Let's try this one. And like this will just kind of allow you to modulate different sounds and kind of edit the different sounds and whatnot, which can be super fun. Oh, and I forgot what to do. Oh, and see here how I made an error. This is what I was trying to mention before, but it finally popped up. It'll just kind of like let you know if there's like a little bug or an error in your code. And usually it'll say the line, which is very helpful. We'll try that again. So I think there's a do after that. And for this one, you can just kind of pick whatever effect you'd like and just play around with that. So with that, you can get a lot of interesting sounds. And then when you kind of pair that with like the synth as well, there's lots of possibilities to make fun noises and sounds and just kind of add an extra like element to your song. And for the last part, so it's pretty much just layering everything that we covered. So probably the easiest way for this is again just copying it right from the chat. And for anyone that's watching the recording, you'll have access to a document with that because it's a very lengthy code. So I'll have that in the chat. So once you're kind of done playing around with that, you can put that into a new buffer and just kind of hear all the elements as one song. And again, with that, you can, once you get that all done, you can edit kind of like the different effects and synths and timing and excuse me, of everything, just to hear the different possibilities. So I'll give everyone like 5 to 10 minutes just to finish up that previous code and then to copy and paste that very long code I put in the chat. And again, that's just kind of like everything that we covered, just layered into one song. So I'll just give everyone about 2 more minutes and then we'll wrap everything up for today. So I'll let everyone just kind of wrap up what they're doing. But that was everything for today's session on Sonic Pi. I believe Trina wanted some type of homework or assignment with this. So with that, main thing is to take some time and just like experiment and play with all the different things that we've covered. And again, you can find like different examples and tutorials to find some additional things that you can add and learn within Sonic Pi. And then I guess like the assignment for this, just because we kind of did like a song that I've kind of created for this, I'd like to assign everyone to create their own, just using the different elements and things that we've went over today. And if there's anything new that you learn with your own exploration, definitely include that. And I guess the best way to save this type of assignment, because again, like it will automatically save on Sonic Pi. But to do that, once you're finished, you can do record, and it will record your code that you did there, and then you can like save that as like an external file and whatnot, and just save that as like a WAV or MP4 file, and then submit that to Trina or wherever you're supposed to submit your assignments and whatnot. So again, like just for the end, we have a little bit extra time. So if there's any questions or anything that me or Tess could answer, you can drop that in the chat, or if there's any comments or anything, feel free to drop that in the chat. And if there's anything else that you'd like to add in, Tess?
Yeah, I just on the recording note, just so you know, because it's a little weird, but you press the recording button, then you still have to play the sound, and then you stop the recording. So you like record, then press run, then stop the recording, and that's how you get your audio. So if you only wanted to record part of it, for instance, you can stop the recording earlier. So yeah, just so you know, that's how you do that. But yeah, definitely spend some time creating your own composition. And yeah, we can hang out here for a bit if there's any questions, if you want to work on creating your own composition right now. But otherwise, we're really grateful for your time this morning, and we're really grateful you joined us because we love Sonic Pi, and we hope it inspired you to love Sonic Pi a little bit as well.
Thank you both so very much. That was wonderful. I had a lot of fun just tweaking it, and I'm already thinking of friends of mine that do more so play instruments. I used to play flute and drums as I was in school, but haven't lately. But a few friends of mine still like create their own music, and I'm like, they could be testing their songs, and if you are just kind of the one person band, then you kind of get to add in all of that extra notes that you wouldn't be able to do even if you are proficient at an instrument. So that's really cool. Yeah, what an amazing tool for anyone that is interested in coding, in music, in everything. So thank you so much for introducing us to that. And if anyone has made their own songs, I would love to hear it. As Cheyenne had mentioned, you can send it along. I'm not, if it's as a video, you could post it in the event feed, and it's just like 1 minute long is the maximum for the event feed videos. But if it's a MP4, which I suspect it is, then it would have to just be emailed to me, and that's cool too. Which is stemforgirls@wrdc.ca. Yes, I had a moment there where I was like, is that my email address? My mind is in music right now, but amazing.
And also, I'll be sending you just like a little document with the codes that we covered today, and some just like little cheat notes and additional resources for Sonic Pi later on today.
Excellent. Yeah, that was certainly a lot to take in by video. So having that kind of document there, that might be a bit of a cheat sheet to help us make music. That would be so great. Yeah, so I don't see any questions. I don't know if any of the students are still playing with it, or maybe you need to take a break, honestly, and walk away from a screen, because it's been a long morning of this. So it's always good to just give your eyes a break, and you can always come back to it. So just throw that out there.
Yeah, wonderful. I'm realizing that maybe the last bit of code didn't send in the chat, so I'm just going to make sure I send it. I think it maybe went into a private message, but let me just send it so everybody has it. And then I'm also just going to drop my email and Cheyenne's email in the chat. So if you're working on this in the coming days and you have any questions, okay, let me make sure that sends. Okay, there's the final code in case anybody didn't get it in the chat. But yeah, if you have any questions in the coming days while you work through on Sonic Pi, feel free to reach out to us. So it's just our names, Tessa and Cheyenne, at pingua.com. So it's Tessa@pingua.com or Cheyenne@pingua.com. But we'll also make sure that that's on the written resource, so you can reach out to us that way.
Perfect. Well, with all of that said, I'll get once I get the document, I'll get that posted up ASAP. So under the video, there's a section, I believe it's called files, very simply. So that's where you'll find that once I have it. And otherwise, I think we'll thank you very much, and wish everyone a wonderful day, and hope that you can enjoy some sunshine today, or at least this weekend, as we approach the end of the summer, just like that.
Yes, well, great. Thank you again, everyone. And I hope you have fun exploring and experimenting with that. And I hope everyone has a great weekend. I guess today's only Thursday. Okay, I hope everyone has a good rest of their day and a good weekend as well.
A happy early weekend and a happy, last few weeks of summer. So thank you everybody again. And thanks, Trina, for having us.
Thank you.
All right, bye now.
Bye.
Bye.